Hello everyone. Now in this lecture we will know about the next concept. That one is a relational decomposition. That one is it's a type of a decomposition when a relation in the relational model is not in appropriate normal form. We already know about the different type of normal form. That one is 1NF, 2NF, 3NF, or the BCNF. The given relational model, or it may be a relation in a relational model, is not an appropriate normal form, then the decomposition of a relation is required. Then we apply the 1NF. That one is one type of a normalization. We can say that that one is a decomposition algorithm, and that one is a decomposition of a relation is required. Then in a database, it breaks the table into multiple table. That one is, we can say that, the decomposition. If the relation has a no proper decomposition, then it may lead to problem like a loss of information. If we divide the existing table into a multiple table, and with the help of that decomposition it lost the information, then that one is again a decomposition problem, that is a loss of information. Then decomposition is used to eliminate some of the problem of bad design, like anomalies, inconsistencies, and the redundancy. Sometime we use decomposition is done because of the remove the some type of anomalies, like insert, update, delete anomalies, or the inconsistency in a database, or it may be a redundancy of the data. Then it is decomposition is used for this type of bad design. Means a two scenario: if we decompose the table, it may be a loss of information, or it may be a decomposition. It's useful as a reducer or remove the problem related to a bad design. With the help of remove this type of a problem. Now the type of a decomposition, or at the time of loss of information, which means we need to take care about the decomposition not run with the loss of information, right? And also remove this type of a problem. Now type of decomposition, it's a lossless decomposition or the dependency preserving decomposition. Now we will know about the one by one. Lossless decomposition means what? If the information is not lost from the relation, that is decomposed, then the decomposition will be a lossless. Means when we divide one table into a two table, and our basic information is proper, or it may be not lost, then we can say that that decomposition is a lossless. The lossless decomposition guarantees that the join of relation will result in same relation and it was decomposed. Means if we have one table, we decompose that table for the betterment or better design, then again a reverse of that decomposition gets a same information at the initial. The relation is said to be a lossless decomposition if the natural join of all decomposition give the original relation. Means after the decomposition we get the new relation, and again a reverse of that new relation we get the original relation. That is, we can say that the lossless decomposition. Then simple example, we have the table, that is employee details, employee ID, name, age, city, department ID, and department name. Now we just to go with the decomposition. Above relation is decomposed into a two relational relations, that is employee and department. Then employee contains a employee ID, name, age, and city. Now the next department ID, employee ID, and department name. This one is a second table. Means it generates a two table with as a decomposition, and when we combine this two table again, here is a combining the two table, we get the original one. Then we can say that the given decomposition is a lossless joint decomposition. This is simple the example. Means when we decompose the original table and we revert the process, then we got the again original situation. Now the next type, that one is dependency preserving. It is important constraint of the database. When we decompose the table, existing table, then the dependency of the particular table or between the attributes we need to maintain. That is the preserving. In the dependency preservation, at least one decomposed table must satisfy every dependency. Means if we have the dependency, originally we have a two dependency and we decompose the table, then at least one of the table after the decomposition maintain all the dependency. If a relation R is decomposed into the R1 and R2, then R either must be a part of here, that is simple, the R relation decompose with the R1 and R2, then R either must be a part of R1 or R2. Now the derived from the combination of functional dependency of R1 and R2. For example, we will go with a simple example. That one is we have one relation, that is R contains A, B, C and D, right? It's a relation with the functional dependency set as A have a relation with B, C. Now the relation R is decomposed with the R1 and R2. R1 is ABC, and R2, that one is AD. R1, R2 as AD, right? Means ABCD as a relation, we divide that in two, decompose it with R1 and R2. Now the dependency preserved because ABC is a part of the relation R1. If we check the original relation as ABC, that one is a part of the R1, as a part of the R1. That's why we can say that the decomposition is a dependency preserving, because of in a given relation that this is the dependency set as an example, and when we decompose the R relation into R1 and R2, then R1 maintain this dependency set. That's why we can say that this decomposition is a dependency preserving. This is simply the decomposition types: lossless decomposition and dependency preserving decomposition. This is simply the explanation about the relational decomposition. Thank you.